This video contains the solutions for the 6263 multiple choice practice and step-by-step problem number 37, I believe. Yeah, number 37. All right. First one here, this is just a straight up antiderivative. Antiderivative of x cubed is x to the 4th over 4 minus the antiderivative of 3x is 3x squared divided by the new exponent plus c. You can do a real quick check, just take the derivative of this, make sure that it matches up to that. It does. And that looks like, well, it looks like e. So no tricks there. Remember that if there's a number in here that you don't want to be there, you can take it to the outside. So this integral is the same as that, taking the 5 to the outside, and that matches up to tangent inverse. So that's 5 times the tangent inverse of x plus c. And remember that arctan, that means the same as tangent inverse. So that's our answer right there. Okay. This one we had in your notes, but I'll just go through that again. So if dy dx equals this, then y equals, if you're trying to get to y from dy dx, it means you have to take the antiderivative. So that's the same as saying, what's the antiderivative of tangent x dx? And we did that by making that sine x over cosine x and doing a U-substitution. U equals cosine x. Trying the thing on the bottom is usually a good bet. Du would be negative sine x dx. Everything looks good except I don't have the negative sign in there, so I'll insert a negative sign in here, which means I need to put another negative sign on the outside. And that becomes negative antiderivative of 1 over u, and my cosine x is the u, and then all this, the negative sign, the sine x, and the dx, that's all du, and that's equal to negative natural log cosine x plus c. So, well, it'll be u, sorry, I cut out one step there. That would be the u, and then putting that back in, that's cosine x. So we look for that answer, and it's not there, but if we take that in, that negative sign, using our logarithm rules, that is the same as this, right? That would flip the cosine over. So that's c. Okay, now into the U-substitution problems. So, looking at this, when you're trying to do a U-substitution, you have to pick a u where it looks like your du, the derivative of that, shows up somewhere. So, x cubed is a good choice because the derivative of that is 3x squared, and I've got the x squared up there. So, I will make excuse me, u equal to x cubed, so du would be 3x squared. Now I don't have that 3 there, so I'm going to go ahead and put a 3 here, which means I will need a 1/3 on the outside. So let's see what that looks like now. That's 1/3 with an antiderivative of 1 over e to the u, or e to the negative u du. Alright, now this is a little tricky. The antiderivative of e to the u would be e to the u, but the antiderivative of e to the negative u is You could do like another substitution here, but it's only this negative sign that we have to deal with. So think about this for a second. If we were doing this problem, right, if this were the whole problem, I would say, well, you could do a substitution, but you know it's just that negative sign that's in there, so it would have to say, this is what the substitution would look like, but I think probably you don't need to do it. I think you probably know that it's going to be negative e to the negative x dx. You could try to take the derivative. When you multiply by the derivative of what's inside, the negatives would cancel out and you would get that. The substitution would look like this. U equals negative x, so du is equal to negative 1 dx or negative dx. So I need a negative out in here, negative outside, and that's how we get this. Okay, so back to here. Antiderivative of that is 1/3 times negative e to the negative u plus c, and u was x cubed. So that means my answer is negative 1/3, bringing that negative out here, e to the negative x cubed plus c. That's what we're looking for. And that is the same as this, right? They just put that negative exponent and they made that on the bottom. So there's a little bit of algebra there, right? Simplifying your answer, they just took that negative exponent and made it happen on the bottom. That would be C. If you're real careful with your chain rule and you can work fast, remember, you can always try taking derivatives of these things, get one to match up. All right, so how about this? Well, this is a very clear what's inside. So I'll let u equal 2x plus 3. Du would be 2. Derivative of that is 2 dx. So I need a 2 in here, which means I need a 1/2 on the outside to balance it out. So that turns into 1/2 the antiderivative sine of u du, right? 2 dx turned into du. And the antiderivative of sine is negative cosine. So that's negative 1/2 cosine u du. Cosine u plus c. And u was 2x plus 3. So looking for negative 1/2 cosine of 2x plus 3 plus c. That's d. How about this? Just by itself, that is the upper half of a circle of radius 2, right? If we're thinking about area. But it's got an x on the outside, so if I think about, could that be my inside? You think about what would the derivative of this be? Since it's an x squared, the derivative would just have an x in it, and that's sitting outside there. So do u is equal to 4 minus x squared. That's the inside. And du is negative 2x dx. I've got the x dx, but I need the negative 2. So I'll insert a negative 2 in there. Means I need a negative 1/2 on the outside. Right? So rewriting this with u's, I get negative 1/2 times the antiderivative of the square root of u and then negative 2x dx all turns into du. That's u to the 1/2. So let's see, what's the antiderivative of u to the 1/2? Bump the exponent up 1 to 3/2, and then divide by the new exponent, and then multiplying that, the 2's cancel out, so that'd be negative 1/3 u to the 3/2, negative 1/3 times u, which is 4 minus x squared to the 3/2. Let's see if we can find that. Things that look like they have a negative 1/3 in them are d and e. And it looks like this has the 4 minus x squared to the 3/2. There it is. Okay. The next two are easier types. It's just a 2x. So if you wanted to do the substitution, remember that if we have dy dx and we're trying to find y, that's the same as finding the antiderivative, right? So I could say, well, u is equal to 2x, du is equal to 2 dx. So I need a 2 in here, need a 1/2 on the outside. So that looks now like 1/2 times the antiderivative cosine of u du. Antiderivative of cosine is sine, so that's equal to 1/2 sine of u, and what was the u was 2x dx. And hey, look, there it is, right underneath. Oops, sorry, dx plus c I meant. Let's see. So remember, like in general, if the only thing that you're substituting for is a multiple times x, you're just going to get that multiple, like dividing by that multiple on the outside. So same thing here. I think that we already know what the antiderivative of tangent is. The antiderivative of tangent in general is the natural log of secant, or negative natural log cosine. And looking at all these, it looks like the cosine form. That's not. That doesn't look like it. Doesn't have any natural logs in it, so that's definitely not right. So it's the antiderivative of tangent is negative natural log of cosine 2x. But because it was a 2x in here, by exactly the same thing we did up here, you're going to get a 1/2 out here. You can go through that substitution if you want to, but same every time. And that looks like B. And look, they've got all the different possible mistakes that you can make. If accidentally you got a 2 on the outside instead of 1/2, they've got that here. If you forgot the negative sign, they've got that covered. So you got to be real careful. It'll be B. And then the last one, this one is a little tricky, a little different than the kind of sine inverse that we did today. If you're thinking this matches up to sine inverse, you're right. It's going to be one of these three, not this. Now, how do we get it there? Well, you could try, if you haven't narrowed down to these, you could try just taking the derivatives of those. I think clearly it's not this, right? The derivative of that would be just 1 over the square root of 1 minus x squared, right? That's just sine inverse. So it's not that. So let's see if we can get this to work. What we're going to do is factor out a 5 from the bottom. Okay? This is kind of a crazy algebra move here. We're going to say that factoring out a 25 from this gives me square root of 25, factoring that out, times 1 minus x squared. Since I factored a 25 out that wasn't there, it's going to be x squared over 25. Whereas the square root of 25 is just 5, so I can move that 1/5 to the outside. There's a 5 right there on the bottom. 1 over the square root of 1 minus x squared over 25 dx. Okay? And now, if I want this to match up to sine inverse, I've got this, I need to make this equal to u squared. Right? This is like one that we did in class. So, sorry, I'm running out of space here. Here, that gives me 1/5. Well, let me write out the u-substitution first. So, u squared needs to be equal to x squared over 25. So, u will be x over 5. And du will be, that's the same as 1/5 x, be 1/5 dx. Now, I don't have the 1/5, so I need that in there, which means I need to multiply by 5 on the outside. 5 times 1/5 is 1. Those cancel out. And I get on the inside 1 over the square root of 1 minus u squared du. And that antiderivative is sine inverse of u plus c. And u was x over 5. So the answer should be sine inverse x over 5 plus c. And that's A. Again, if you got as far as this and you realized, well, it's got to be some kind of sine inverse, and it can't just be regular sine inverse because of the 25, you could just try taking the derivatives of those two and see what happens. That'd be a pretty quick way to get to the answer also. All right, let's look at this step by step. We've got two functions. The derivative of the f function is this, derivative of the g function is this, which, since we're just dividing by the same thing here, dividing by x to the 1/2, x to the 1 divided by x to the 1/2 is x to the 1/2 minus 1 over x to the 1/2 is x to the negative 1/2. So that's a much more calculus-friendly version of that when we get there. I'll take care of that right now. Okay, so if it's known that f of 1 equals 5, find f of x. Well, finding f of x is taking the antiderivative of this. All right, so f of x is the antiderivative of this. So bump the exponent up by 1, divide by that exponent, that's x cubed minus x squared minus 2x plus c. All right, take a second to check that. And gave us a point here. That's the point 1,5. So that means I can solve for c. So 5 is equal to 1 cubed minus 1 squared minus 2 times 1 plus c. So let's see, be careful here. 1 minus 1, those cancel out, minus 2. So it looks like c is 7. So f of x is equal to x cubed minus x squared minus 2x plus 7. Right? To get back to an f function from f prime, we take the antiderivative. And since they gave us a point, we could solve for c. If they didn't give us a point, then we'd still just have the plus c there. Okay? Using the answer from part A, find the x value guaranteed by the mean value theorem on f on the interval from -1 to 1. Well, the mean value theorem says that the average slope equals the derivative somewhere in that interval. So first I need my 2 points to find the average slope. So -1 comma, here's my f function. So plugging in -1 into this, I get, let's see, where should I do the work here? I do it over here. So f of -1 is equal to -1 cubed minus -1 squared minus 2 times -1 plus 7. That's -1 minus 1 plus 2 plus 7, which is equal to 7. So there's my first point. And then the second point is what I get when I plug in 1. So f of 1 would be equal to 1 cubed minus 1 squared minus 2 times 1 plus 7. And that's 5. So my slope here would be y minus y over x minus x. Careful with your signs. Make sure you're going the same way. In other words, y2 minus y1, x2 minus x1. It's negative 2 over 2. So the slope is negative 1. The way the points would be distributed for this, that would probably be worth a point, finding that slope there. Now the mean value theorem says that somewhere average slope is equal to the derivative, right? Average slope equals like instantaneous slope or exact slope, or in other words, derivative. So I need to take that negative 1 and set it equal to the derivative, which they gave us, right? That's how we found this in the first place. It's 3x squared minus 2x minus 2. So let's see if we can do that. Add 1, and we'll see, since this is not a calculator problem, this probably factors. It would have to be 3x and x, and 1 and 1. Let's see, can we get a negative 2 there? If that were negative and that were positive, that would give me minus 3x plus 1. That's what we're looking for. And that gives me two answers. Gives me x is equal to negative 1/3 and 1. So are those the answers? Well, remember the mean value theorem says that we have to find an answer that's in this interval, that's inside the interval. So the 1 actually doesn't count because that's at the edge of the interval. This is the x value that I'm looking for. You probably get all the points except for 1 if you gave both of those as answers, but 1 actually does not count. The mean value theorem says we've got to find one inside the interval. That would be negative 1/3. All right, part C. They want us to show that the answer to part B would be the same if there was no information given about the value of f at any x value. In other words, if we didn't have the plus 7, if we couldn't have solved for plus c, would we still get the same thing? And a couple ways to reason through that. If you want to reason through it, you think about the only difference that the plus c makes, the plus c, is that it lifts the function, it shifts it up or down. So neither the average slope nor the instantaneous slope, neither one of these things should change if we shift it up or down. But they want us to really show that that's true, so let's see if we can do that. If we plug in negative 1 into this without knowing, in other words, if this was not a 7, if it was just a c, then what would we get? It would look exactly like this, except the 7 would be a c, right? We'd have negative 1 minus 1 plus 2 plus c. We wouldn't know what this was. So that would just give me, I think this would all cancel out and I'd just get the plus c, right? I'd get minus 1 plus 2 plus c. So that would give me a y value of c. And then when I plug 1 in, I would get 1 minus 1 minus 2 plus c. That would be, let's see, 1 minus 1 cancels out. That would be minus 2 plus c. And let's see, what would the slope be between these 2 points? Well, y minus y would be negative 2 plus c minus c over 1 minus negative 1. And negative 2, the plus c and the minus c cancel out. 1 minus negative 1 is 2. And sure enough, we get the same slope. Right? The c's canceled out. That's the algebraic evidence that the raising the function up or down didn't make any difference. The c ended up canceling out. It didn't matter. And now we want to set that equal to the slope, which is 3x squared minus 2x minus 2, right? That's our slope from up here. And of course the slope didn't have the plus c in there, so from here the work is the same as part B. x is equal, right? I mean, this is exactly the same equation that we solved in part B. So you don't have to do that again. It would be negative 1/3. We'd get the two answers, only one of them is inside the interval. So we just sort of showed algebraically that the c doesn't matter. The c would cancel out and we'd get the same slope regardless. So it didn't matter what the point was that they gave us. The answer to this question would be the same. And last, they want to find the average rate of change of g on the interval 1, 4. Well, let's see. We don't have the g function. We know that g prime, the derivative, is equal to, from above, it's x to the 1/2 minus x to the negative 1/2. So the g function would be, let's see, the antiderivative of this, we bump that up to 3/2 and divide by the new exponent, and then bump that up to 1/2 and divide by the new exponent. Dividing by 1/2, same as multiplying by 2, plus c. Okay? Now they want the average rate of change. That's an actual slope, right? So I need to find g of 1. That would be, oh, notice here, they didn't give us a point on the g function, so we can't solve for c. But after having done this part, I think we should be reassured that the c's actually are going to cancel out. We don't need to know what they are. So let's see if that happens again. It should. So I get 2/3 times 1 to the 3/2 minus 2 times 1 to the 1/2 plus c. That's equal to 2/3 minus 2 plus c, which is equal to 2/3 minus 2, that's negative 4/3 plus c. Okay, now I need to find g of 4. Right, that would be the other point. So g of 4 would be 2/3 times 4 to the 3/2 minus 2 times 4 to the 1/2 plus c. That's equal to 2/3 times the square root of 4 is 2, cubed is 8. The square root of 4 is 2 times 2 is 4 plus c. That's 16/3 minus 12/3. That's positive 4/3 plus c. Okay, so the 2 points that we have are the points 1, comma, negative 4/3 plus c, and the point 4, comma, 4/3 plus c. Finding the slope, I do y minus y over x minus x, which gives me, notice that the c's cancel out just like we were hoping, right, expecting. So I have 4/3 plus 4/3, that's 8/3 over 3, and that's equal to, 8/3 over 3 is equal to 8 over 9. So the average rate of change on G is 8/9, and notice we were able to find that even though they didn't give us a point on the G function, because it doesn't matter. It doesn't matter whether you shift it up or down. All the stuff about slopes is the same.